we're just going to talk about square roots today. So most of the stuff we've actually already kind of talked about and already did on our calculator, so it's a good little review. And then we're going to get into the next lesson, which is lesson 6, and it's converting radicals, and you're going to see what that means. Okay? Let's start off with roots. So we're going to talk about square roots. What square roots do? They've got an example there. Square root of 16. Okay, they talk about it right here. What is square root? Does anyone know what a square root is doing? Like, some of us know like the square root of 16 is 4, but do we know why it's 4? Good question. Okay? Like, we understand division if we said like 6 divided by 2 is 3 because it breaks into 2 groups, right? And then 3 and 3 would be 2 groups to get to 6. We know what multiplication means. Like 4 times 2 means 4 groups of 2, which would give you 8. Right? And sometimes people just forget what a square root's actually doing. Okay, so a square root is breaking a number into 2 numbers that if you multiply them together, you would get the original number back. So for instance, when you do the square root of 16, you get 4 because 4 times 4 equals 16. And it breaks something like perfectly in half so that if it multiplied by itself, you get the original thing. That means technically you could get a positive or a negative answer because negative 4 times negative 4 would also be 16. Now, we only deal with what they call the principal root. That means the positive answer. We don't deal with the negatives. You might see that somewhere, like in the textbook, or even just talking about math or learning from a tutor or something. They might talk about the negative version, but we don't really need to do that. Okay, we just do the positive version until next year. Awesome. If you did square roots, you usually get irrational numbers. A reminder that irrational numbers are numbers that get decimals that never end. Right? If it's not an irrational number, it's typically like a whole number, like 4. Right? A really nice number like that. There's a lot more irrational numbers than rational numbers. Just warning you. Okay? The next thing that we learn about is a cube root. So a cube root looks the same as a square root sign, but it's got a little 3 right there. We're going to talk about what that number is called in a minute. A cube root is taking a number and breaking it into something that if it was multiplied by itself 3 times, you would get the original thing. So for instance, if you took the number 1,000 and you took the cube root of 1,000, that means that 10 times 10 times 10 would equal 1,000. So a square root is breaking something into 2. This one's breaking it into something if multiplied by 3. And you could probably guess that means a 4th root's taking a number and breaking it so that it multiplied by itself 4 times. Would work, right? And you can keep going higher and higher and higher. Awesome. Where these buttons are on your calculator, the square root and the cube root, we have done this. It's just maybe a good little reminder of how to work our calculators. If you have a phone or a different calculator, it's in a different spot on your calculator. I'll go over these ones because that's the most common calculator we have right now. If you're using something else, just let me know, right? And be like, I don't know where my cube root button is, and I'll show you. Okay, we'll find it together. But for those of us who have the TI-83 calculator, the square root button is blue. It's right there. So to use it, you would go second and then click that x squared button. So second and then that thing, and it would bring the square root symbol up on your calculator. Okay. So second, which is here. And then if you go down 1, 2, 3, 4, you'll see a little blue square root symbol. You click that one. It's not actually on the button, it's above the button. Awesome. The cube root button is hidden. It's in a menu somewhere on your calculator. So if you've got a calculator like this and you want to see the cube root button, you have to hit math. When you hit math, I believe it's the 4th option. Yeah, it is. The 4th option, you'll see a little cube root symbol. Awesome. If you want to do any root bigger than the 3rd root, so if you want to do the 4th root or the 5th root or the 6th root, what you do is you go back to your original screen. If I wanted to do, say, the 5th root, I would type in a 5, and then I would go math, and you'll see that the 5th option is a little x and then a root symbol. By typing 5, that's telling the calculator I want 5 to be the x, and then I would pick that 5th option. Okay. We don't really do roots bigger than 3. Maybe you'll see the odd one, but it's pretty rare. The best way to learn this stuff is to practice and use your calculator lots. Okay, so whatever calculator you have, just practice. Right, try finding some square root buttons, see if you can do it. The more questions you do in this class, the more you'll find them, and the easier it'll be. And so practice is the way to do it. Awesome. Let's talk about the parts of a radical. There's instructions right there. Top of page 34 on how to use the X root. If you're ever confused. This slide, this is my favorite slide that we talk about. It's at the bottom of page 34, I believe. Okay, we're just going to talk about the parts of a radical because there's specific names, and I will use that terminology, so you need to know that terminology. Otherwise, it's very hard, right? They have the square root of 39, sorry, cube root of 29 right here. Awesome. When you look at a root, there's three things to it. There's the root sign. Yeah, that's pretty obvious. So the root sign is this guy right here. That's just the symbol. Then you have a little tiny number that goes kind of like on the elbow up here, like this little spot. This number right here. In our case, it's a 3. That little number specifically is called the index. And the index is going to be important to us in our future lessons because I'm going to refer to it a lot. I'll say, what's the index? And you're going to be like, oh, it's a 3, right? The index is a 3. All right, say, what's the index? You say, the index is a 5, right? And you need to just know what the index is when I say that phrase. If they don't write an index, so if they did something like this, square root, 9. Typically, when we don't write something in math, it's a 1. Right? For indices, I don't know how you say that. If there's no symbol there, it's an invisible 2. Okay, so when you see a square root symbol like that, this thing, index 2. Awesome. The next word that you're going to need to know is representing the thing that's underneath the root sign. So if you look right here, I'll often refer to that as the thing under the root sign. And then as we get better and better, I'm going to use the proper terminology. The thing under the root sign is called the radicand. Okay, they've spelled it out for you. So radicand. And we're going to talk about simplifying radicals, converting radicals, and it always has to do with changing the radicand value. We're going to change it to different numbers. Awesome. There's one other term that I want to go over that's not on this. So if you had a root, I didn't like the circle around that, right? Let's do this. Cube root 29. If there was a number in front of your radical, so if there was like any number, I'm going to use the number A, the letter A, to represent any number that would be in front of a radical. What do we call something that's in front of something like that? If you remember. That thing's a coefficient. Can you see that green color when I use it? Is it too bright? You can see it? Okay. So if there's ever something in front of a radical, we refer to it as the coefficient. Coefficients are multiplying, right? So this would be A times the cube root of 29. Those are the three terms I'm going to use the most. Index, radicand, coefficient. If you know all three of those, and as you watch us do math together, you'll understand what I'm talking about a heck of a lot easier if you remember what each thing is. Awesome. You might even get a question on a quiz or a test that says, what's the value of the radicand? Just so I know you know what we're talking about when I'm talking about math with you. Fantastic. I'm going to slide down here. So if we look at this one, classroom example 4, we're just going to identify the parts of the radical. This first one, what's the index value of that thing? Yeah, it's a 5, right? The index is the little number right there. It's 5. The radicand value is, okay, I'm 75. The thing underneath the roots. You do the next two, just so we all are on the same page. So write down what the index is, write down what the radicand is. The index for this one would be a 2. The radicand, a 15. Right? Index is the little number on the elbow. If it's not there, it's a 2. The number underneath is called the radicand. Looking at this guy, the index is the little number on the elbow. It's a 3. The radicand is this entire fraction, and it's a negative radicand. So it's negative 1/10. The 5 in front, we would call that a coefficient. Beauty. That's a pretty dry start to the radical lesson, right? People are like, yeah, okay, keep going. I want to make sure that we have the right definitions down, so when I talk about it, you don't get completely lost. Okay, we're going to fast forward. Stuff all basically adds up to what we're about to do, which is lesson 6. There we go. We're going to convert some radicals. All right. There's 2 rules that we're going to use. We're going to talk about them in general, and then you're going to see what it actually looks like. Okay, so the rule is that if you have 2 radicals multiplied together, and they're the same radical, so they're both square roots or they're both cube roots, like they're the same index values, then you can actually combine 2 radicals into 1 radical by multiplying the radicands together. Okay, so I could take 2 separate radicals, combine them into 1 radical. That means I could also do that same rule in reverse, right? If I had 1 radical with 2 radicands, I could break it up into 2 separate radicals. Okay, so if I had this, right, square root of a times b, 2 radicands means I could chop that thing in half, and then all of a sudden I have a radical times another radical. We're going to do that, but with numbers. Okay, we're going to go both directions. I don't like those approximating ones. We're going to fast forward to this part. A couple more definitions that we're going to learn. We're going to learn something called an entire radical, something called a mixed radical. So an entire radical is something that doesn't have a coefficient. So for instance, if you look at this, square root of 80, that thing has no coefficient. No coefficient means entire radical. Okay. Typically, we start with entire radicals, and we want to change them into something called a mixed radical, which means it does have a coefficient. If you look at this guy, it does have a coefficient. This one does have a coefficient. Okay, we call those mixed radicals because there's coefficient and a radical sign. We're going to convert between the 2 forms. Typically, starting with entire, going into mixed. Awesome. Sometimes we go the other way too, although it's just not quite as useful for us in the future. It's way more beneficial to have a mixed radical, which is why we do that more often. All right, converting. Let's convert. This is the actual meat of it all. So, we'll start off with a couple class examples. We have the square root of 108. The question is to convert it into a mixed radical. Convert root 108 to a mixed radical. That means we want a coefficient. Right? The way that you're going to do this is by using something called your perfect square chart. Your perfect square chart's actually provided to you in this textbook. It won't be provided to you on quizzes or tests, so you would have to make it yourself. The way you would make your perfect square chart is you just take the first 10 or so numbers and you square them. Okay, so the number 1 squared equals 1, right there. The number 2 squared equals 4. The number 3 squared equals 9. And these are all perfect square numbers. That's your perfect square chart. Okay, 1, 4, 9, 16, 25, 36, 49, all the way down. Typically, you don't need to go past 10. every once in a while you do those, so it's good to maybe have the first 15 or so. The more you use them, the more you'll know them. Okay, so eventually you should get to a point where you don't need to make the chart anymore. You just know the first 10 or so perfect square numbers, because we're going to use them a lot. Our goal now is to take our radicand value, so it was 108, and we want to find the largest perfect square number that divides into 108. And I don't know what the answer is. So what I'm literally going to do is I'm going to take my calculator and start dividing it. Okay, I'm going to go 108, and I'm going to divide it by 100. And it's going to give me a decimal, and it doesn't work. And I'm going to go 108, and I'm going to go divide it by 81. It gives me a decimal, it doesn't work. And I'm just going to keep working my way up until one of them divides perfectly into 108. Eventually, I work my way to 36. I go 108 divided by 36. 108 divide by 36. And my calculator tells me the answer is 3. What this means is that I can take the number 108 and I could change it to be 36 times 3. Right? It's the same thing. 36 times 3 is 108. So that's what I'm going to do. I'm going to take my radical, 108, and I'm going to change it to be 36 times 3. So I have 2 radicands here. The reason that would be beneficial for us is that lesson that we learned where we can take 2 radicands and chop them in half, right? So if we have 2 radicands, we chop this thing up, and we create 2 separate radicals. One with 36, one with 3. That's just a math rule we have. Okay? 2 radicands can break into 2 separate radicals, but they have to be multiplied. The reason that would be beneficial is we picked a perfect square number that divided into 108, right? It came off our list. All of these numbers, you could square root them, okay? Because they're perfect square numbers. That means if we look at this guy, I can actually calculate that. When I calculate that, it gives me 6. That means I now have 6 times root 3. I can't calculate root 3. If I put it in my calculator, it's an irrational number, right? So it doesn't work. That means I now have a coefficient, 6, and I now have a radical, root 3. My answer is 6 square root 3. I took an entire radical, root 108, and I converted it to a mixed radical, 6 root 3. Typically, the first couple times you see this, it's kind of like, woo, that was a lot of steps, I don't know what's going on. But you will find that this is very much like mechanical. It's like just step by step by step. And the more you practice, the more you see it, the easier it is to be like, okay, I know what the next step is. All right, so we'll do a couple more together, and you'll probably be like, yeah, okay, I get it. Awesome. Let's try 3 together. We're going to convert the following radicals to mixed radicals in simplest form. First thing we do, we look at our question. It says square root 50. Because it's a square root, I'm looking at my perfect square chart. Okay, that's why I'm choosing this perfect square chart up there on the side. Now what I do is I look at my perfect square chart. I've circled it in the purple there on the side. And I want to find the biggest one of these numbers that divides into 50. Okay, as you're going through and you're checking and you're like, oh no, 50 divided by 36, 50 divided by 49. You're going to do 50 divided by 25. And you're going to get that the answer is 2. That means I can take my radicand and I can break it up to become 2 radicands. 25 and 2. I took 50, I broke it into 2. The reason I do that is that there's a math rule, and the math rule says when you have 2 radicands, you can break it up to become 2 separate radicals. It's supposed to be times root 2. Right? That's just our math rule. The reason that's beneficial to us is because we picked a number that is a perfect radicand, perfect square, whatever you want to call it. We can calculate this thing. We can actually put in our calculator, go square root 25, and you'll find it equals 5. That is now my coefficient. The square root of 2 is now my radical. I've successfully converted my entire radical into a mixed radical. Awesome. This process is called simplifying. So you might see it say convert to a mixed radical. You might also just see it say simplify. Awesome. We're going to simplify root 45. Okay, so I want everybody to try to find the perfect square number that divides into 45. So you're looking at that chart on the right-hand side of your page. You want the biggest perfect square number that divides into 45. I'll give you a second with your calculators to maybe do some guessing and checking. Okay, by guessing and checking with my calculator, I eventually found that 45 divided by 9 worked. And I got 5. 45 divided by 9 gave me 5. And I guessed and checked to figure that out. What I can do now is I can take that 9 and that 5, and I can rewrite this to be 9 times 5. Okay, I took my radicand, I rewrote it as 2 radicands multiplied together. Awesome. The reason we do that is there's that math rule, right? That math rule says I can cut it in half. 2 radicands means I can split it to become 2 radicals. Root 9, root 5. The reason that's beneficial to us, this thing can be calculated to be a whole number. It equals 3. The root 5 remains root 5. And that is my final answer. 3 root 5. Awesome. I want you to try the square root of 320. Try to simplify it all the way yourself. Remember that simplifying has to be the biggest perfect square number that can divide into 320. Sometimes there's more than one number from your chart that works. You have to pick the biggest number. Okay? So just make sure you don't fall for that trick. Go ahead and see if you can simplify that thing. I'll give you a minute, but I'll still run through it with you. 320. 320 is a tricky one. The reason 320 is a tricky one is it's divisible by 3 different perfect square numbers. Okay, I could do 320 divided by 4, and it works. I could do 320 divided by 16, and it works. But I could also do 320 divided by 64, and it works. You want to always pick the biggest one, okay? When you're simplifying something, you want the smallest possible radical to be left over. That's why it's important we pick the biggest possible number, okay? Awesome. 320 divided by 64 equals 5. That means I could take 320, I could rewrite it to be 64 and 5. Now you might notice that I've been doing something and not really mentioning it. I've been always putting the perfect square number first, and then whatever's left over second. It helps me keep things nice and straight and linear like that. Okay, technically you could go 5 and then root 64, but it's better to go the perfect square number first, so then everything stays like in line with itself. Okay? So when you find what divides in, this number goes first. Beautiful. We chop that thing in half. Okay? So we cut it up. We now have root 64. Sounds like a 10%. And root 5. The first one can be calculated to become 8 root 5. If you did different numbers, so if you had done 2 or 16, I think you would have come out with something like 4 root 20 or something like that. And the reason I know that's not simplest form is because 20 could be divided by another perfect square. And so that's how you can kind of self-check your work. My radicand shouldn't be able to divide by any of the other perfect square numbers. Like 5 can't be divided by any perfect square number. That's how I know I'm done. And that's how I know I didn't make a mistake. So if you're ever curious of like, oh, is that actually simplest form? That's how you know. By checking your radicand. Beautiful. We're going to go the other direction. Oh no, we're going to do harder ones first. Aha. These guys. So it says convert the radicals to simplest form. If you look, these are all mixed radicals. Well, the first two are. The third one's a fraction. But the first two are already mixed radicals. Right? There's already a coefficient out in front. If there's already a coefficient out front, what we're going to do is ignore that coefficient for a little bit until the very last step. And we're going to treat this radical the same way we treated the ones above. And we're just going to try to simplify. If we look at 192 and we start dividing it by perfect square numbers, 192 divided by 49 doesn't work. 192 divided by 36 doesn't work. 192, maybe I should have started higher. Like 64 would be perfect. So if I go 192 divided by 64, I get 3. That means this thing becomes root 64 times 3. Again, I'm not going to worry about that 2 out front, that coefficient. I then could break this up to be root 64 and root 3. I could then break this up to become 8 root 3. All I did was simplify it like I always do. Now, I've got to deal with that coefficient that was out front. What do coefficients mean to do again? What operation do they do? Do they mean to add, subtract, multiply? People are like, multiply. It means to multiply, yeah. So if we think of that, and we think, well, what a radicand or, a coefficient actually means, and it means multiply, that means I could have had 2 times root 64 root 3. I could have had 2 times root 64 times root 3. That means I still have 2 times 8 times root 3. I now have 2 coefficients. When I have 2 coefficients, I multiply. It says multiply. You just wouldn't know because the program's not fantastic. Right? So now that you have 2 coefficients, you multiply those 2 coefficients, you end up with 16 as new coefficient, and root 3 is still root 3. That didn't change. Right? My coefficient only multiplied with another coefficient. Awesome. I can do this with anything. So if it was fractions, if it was decimals, the same rules still apply. If you look at b, I have a fraction out front now. Okay, it's still a coefficient. I'm going to treat it the exact same way I treated the other coefficient. I'm going to simplify this guy. When I simplify that guy, I come out with root 16 times root 10. That means I end up with 4 root 10. This guy, the 3 over 4, it's a coefficient. It still followed me all the way to the very end. So I have 3 divided by 4 times 4. Those are my 2 coefficients. My calculator can do this. I just need to put the 3 divided by 4 in brackets. And then I multiply these 2 things. So in my calculator, I would go bracket 3 divided by 4, close the bracket, then times 4. And I get an answer of 3. The root 10 is still root 10. And that's my final answer. 3 square root 10. Fantastic. I'm going to do C with you. In reality, you're not going to see radicands that are fractions very often, if ever. Next year, that really starts to take off. Okay? This year, not so much. If you do see one like this, you have root 7 divided by 9. We're going to use that trick said, when I have two radicands multiplied together, I could split it apart. The rule applies for division too. So if I have two radicands that are divided, I can split them apart. They become root 7 divided by root 9. Okay, so two radicands that are being divided can be split apart into two separate radicals. Then you're going to simplify each radical, like a separate question. The square root of 7 can't simplify. Okay, there's nothing that divides into 7. It's a prime number. The square root of 9 already is a perfect square. So you're going to calculate just that part. When you calculate just the bottom part, it equals 3. Meaning that my final answer is root 7 divided by. Fantastic. I'm going to give you guys about